Hey guys, this is Advanced Math, and we are starting Unit 7 on Statistical Measures and Probability. We've got a lot of definitions today, so let's just jump right in here and talk first about our biblical correlation. This passage from Luke 6 is a story you're probably familiar with when Jesus tells the parable of the man who builds his house on the rock, and the flood came, and it doesn't knock down the house. It doesn't shake it because it's well built. But then there's somebody who doesn't build their house on the rock, and Jesus compares this to the person who hears his words but doesn't put them into practice. And that person builds a house but doesn't have a strong foundation, and the floodwaters knock that house down. And as we start to talk about statistics and probability, we're really going to talk a lot about data and understanding information. And as a consumer of information, you need to know what's true and what's not true. And you need to be able to form your opinions and your beliefs on what is true and what is proven true. And in the world, that comes from data and statistics and things happening repeatedly. And we see in Scripture, we know that His word is true also, again, based on experiences and stories and based on historicity and evidence. And we take all these things into consideration so that we can form our beliefs based on information that is true. So as we jump into statistics and probability, we'll talk a lot about being wise consumers of information and seeking out the truth, not just spiritually, but in all facets of life. Our lesson objective for today is that you, the student, will discuss qualitative versus quantitative data and the difference between a census and a sample. You'll also identify a group of objects as most likely population or sample, and in the future, we'll find the range, mean, median, and mode for a set of data. We're not going to get to that part today. That second part of that objective will come in our second lesson. All right, but let's dive into all these definitions that we've got. First, we know that we need to know what statistics is if we're going to study that. And statistics is the branch of mathematics that deals with collecting, organizing, analyzing, and reporting quantitative information. And we'll talk about what the difference between quantitative and qualitative information is in just a second. But essentially, statistics is the branch that collects numerical data. It organizes it, it analyzes it, it reports it for consumers like us. And the statistics is involved with data. Data is the collection of facts, such as values or measurements. Now, there are two different kinds of data that mathematicians or researchers can collect. The first type is, you'll see in your notes, quantitative and qualitative. So when we talk about data, it can be numbers, which is quantitative, or words, measurements, observations, or even just descriptions of things, which is more qualitative. So qualitative data is descriptive, while quantitative, if you think about the word quantity, is numerical. Qualitative data in the world of research has to do with people's experiences, people's stories, it's their perceptions, their beliefs, while quantitative data is more like what a doctor might collect, how often are you coughing if you're sick, or how many hours of sleep did you get, or how many glasses of water are you drinking each day. These are all things that are numerical. So quantitative and qualitative are the two branches of data collection and statistics. Now, quantitative data can be further broken down. The first type of quantitative data is discrete data. This is when data can only take certain values, like whole numbers. It's counted. For example, if we were wanting to know how many legs were on a dog, and we said 4, this is discrete data, 1, 2, 3, 4. It's not growing, it's not changing, it's a set number. Continuous data, on the other hand, can take any value within a range, a unit of measure, and it is measured. So we might measure how much water is collected overnight or how much snow falls on a daily basis during the winter. And these numbers are going to change, and so we have to measure them, not count them. Here's a chart for you, just kind of breaking this up and summarizing it. We have qualitative data, that's our descriptive data. Again, we said people's opinions, beliefs, and feelings. And then quantitative, which is numerical data, like a quantity. And that's either discrete, counted, or continuous, measured. And let's talk about some data and what we know about this dog here. From a qualitative standpoint, we know a lot of things. We could describe this dog in a lot of different ways. We could say he's brown, he's black and white, he has short hair, he has lots of energy. Maybe you think he's cute, maybe you think he looks sad. There's all kinds of qualitative data we can gather here. From a quantitative standpoint, Our discrete data might be that he has 4 legs, or he has 2 brothers. Some continuous data might be that he weighs 10 kilograms. This is something we have to measure. It could change if he gains or loses weight. And he's 32 centimeters tall. Again, this is something that we have to measure. We just can't see with our eyes and count it. And again, it could change. All right, when we collect data, there's a couple of different ways that we can do that. One way that data is collected is by doing a survey. And the simplest way to do a survey is just direct observation. If we wanted to take a survey, for example, of the types of cars that teachers and students drive, we could go out and look at the cars and either sort them by the type of car or the color of car just through the process of observation. Another example might be that you want to find how many cars pass by a certain point, maybe in front of the school, how many cars pass by a certain point on a road in a 10-minute interval. We can go and collect this information just by observation. A census is another way of collecting data, and this is a way of collecting data for every member of a group, like the whole population. You know that typically when we refer to a census, we're talking about counting the population. Another type of way to collect data is through a sample, collecting data for just selected members of the group. So there might be 120 people in our club or 120 people in our school, and if we ask everyone in our group, all 120 with their ages, that is a census because we've counted for every member of this group. But if we just choose some people, maybe just the people who are here in an afternoon or here in the morning, then that's just a sample of that population. Now, the census is the most accurate because it gets data from every single member of a group, but it can be hard to do. It can be hard to get everyone to respond. A sample is not as accurate because not everyone's represented, but it may be good enough to point out some trends to us or some information that we can base our decisions on. It is a lot easier to take a sample than a census. When collecting data, you heard me kind of throw out these 2 words already. We either collect it from the population in its entirety or from the sample. The population is an entire set of objects or people or things that share similar characteristics, such as human beings, automobiles, measurements, from which data can be collected and analyzed. A sample is just a portion of the population from which data is collected to estimate the characteristics of the entire population. So while the entire population gives us information about every single member, the sample just gives us some of that information, and then we kind of estimate and come to generalities based on just that sample. You know, if we survey 100 people out of the United States, clearly that's not the entire population, but that 100-person sample might give us some ideas about what the current beliefs are regarding politics or the war in Ukraine or whatever else we're questioning them about. We've already talked about statistics being the branch of mathematics that collects and analyzes and reports data. And a statistic, now not the branch, but a statistic, lowercase s, is a measure calculated from a sample of data. A parameter is a measure calculated from data for an entire population. All right, let's see if you can identify these groups as either samples or populations. So we have the snacks dispensed from a vending machine during its existence. Do you think that's a sample or is that the entire population? This is the population because all snacks are being considered. We're not studying just, the snacks in A5. We're looking at all snacks. What about 100 freshmen from among those enrolled at a local college for the fall of 2018? Hopefully you recognize this as a sample when you see that word among those enrolled. There are more than 100 freshmen enrolled, but we're only going to sample a small number of them, 100 of them, for our research. What about the automobiles built by General Motors in the 1990s? Well, this would be a population because we are considering all of the automobiles produced by the company in that time period, the 1990s, not just certain models. What about a school official gathers data about students at Union University when studying the majors offered at the university? Hopefully you said this was population because it didn't specify a certain number or a certain group. It's just all the students at the university. All right, what about this one? A magazine wishes to determine the political viewpoint of college students, so it sends a questionnaire to all students at Union University. hopefully you recognize this as a sample. If it wanted to survey the population, it would have to send the survey to all college students everywhere. But instead, it sends it to just one small college, one sample, to see what their views are. There are different ways that we can collect our samples, or that we can do sampling when we are gathering data. The first way that we can do this is random sampling. In random sampling, each element in the population has an equal chance of occurring. This is a lot like putting names in a hat and drawing names out, or using a random number generator. Everyone has an equal chance of being chosen. There's no method, it's just random, and this is typically considered the best type of sampling. The second type of sampling is called systematic, and this is where the list of either all the elements or all the cars or all the people is counted off. That is, every nth or kth element is taken. So this would be like lining people up and counting off 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then you sample every fourth person, for example, gets to answer your questionnaire. So it's not as random as a random sampling because people can be lined up in any order, but it also is a little bit different in that not every element has an equal chance of occurring and is systematic. It has an order to it. The third type of sampling is called convenience sampling, and this is when readily available data is used. If you've ever been to a mall or to a theme park, a lot of times there will be people there with iPads, and they will stop you and say, "Do you mind if I ask you a few questions?" This is convenience sampling because they're only questioning the people who happen to walk by them, the people who are convenient and available. The last type of sampling that we'll learn about is cluster sampling, and that's when the population is divided into groups, usually geographically. If somebody wanted to do a survey, for example, of high school students in Frederick County, and they only went to Sharando High School, that is a cluster sampling because you're only doing a part of the population, and it's the part that lives in Stevens City, that geographic area. So that's an example of cluster sampling. Now let's see if you can do this on your own and identify the sample as random, systematic, convenience, or cluster. All right, math teachers who attend a workshop at the regional conference. We want to survey those math teachers. What kind of sample are they? That is a convenient sample because they are there. It just happens to be convenient to ask them to complete a survey. What about every fifth person on a class roster? Hopefully you notice this was systematic because we're numbering off 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and questioning just the fifth person. All right, 500 voters based on phone numbers chosen by computer-generated selection of page number and column in the phone book. That keyword there is computer-generated selection. Think of a random number generator. This is a random sampling. It's just choosing randomly page number and column. Okay, a worker selects the first phone number from every page of the phone book for a phone survey. See the first phone number, every page, going in an order in a systematic fashion. To evaluate rates for the country or county-wide school system, the school board randomly selects 2 high schools and evaluates the data at those 2 schools. Now, don't be fooled by the word random, because yes, they are chosen randomly, but within the schools, the students are not chosen randomly. Those schools represent just a cluster of the data, cluster, for example, of the county. So that is going to be cluster sampling. All right, guys, for the last part of your notes you see there, you need to list 3 qualitative facts about yourself and 3 quantitative facts about yourself. Tell me if these facts are discrete or continuous. Remember, qualitative tells facts, opinions, beliefs, feelings, and quantitative tells things that can be counted or measured. Be sure to fill out that last column there so I know that you heard and followed the instructions, and I will see you in class.